It's called gang or impact system dynamics. So we have this problem here. We have a crate, and we're pulling a force P on it, and our goal is to find the acceleration at t is equal to 2 seconds. So we know it has static friction and kinetic friction, and that force is changing with time. So let's go ahead and solve for it. So there's kind of two steps you could approach this problem with. The first one is the crate even going to slip at 2 seconds? So of course our static friction is greater than our kinetic friction, so we don't know if our force is even going to be strong enough to pull it out of static friction by the time we reach 2 seconds. So that might be an approach you want to take. And then after that, if we find that it is slipping, then we can just go ahead and solve like we normally would. So I'm going to go ahead and I'm going to find out first if it slips or not. And then after that, I'm going to solve for the acceleration at that time. So if you want to just skip all of this work to prove that it slips at a certain time before 2 seconds, you can skip forward in the video now. But let's go ahead and solve for seeing if it slips. That's how you'd want to approach this problem in real life. So of course we want to make a force body diagram. Let's start with that. This is a pretty ugly graph, but you know what I mean. Okay, so of course we have gravity pulling down, so force of gravity. And we're going to have force of normal pulling back up. So we have this P force here, and then we have our friction here. This is 20 degrees. So what's our goal here? Well, we want to find acceleration in the x direction, right? We want to find when that force P becomes greater than that force F. So let's start with some of the forces in the x. We know it's going to be equal to, we're going to set it equal to 0 because we're going to assume that we're at equilibrium. And we're going to find out basically if ever this breaks, if that force becomes greater than the friction. So we're going to have P cosine of 20, right? Because P is pulling at an angle, so we got to take the cosine in the x direction and then subtract that frictional force. For expanding this, we get P cosine 20 minus coefficient of static friction times normal. So writing this in terms of P, we're going to get that P is equal to coefficient of static friction times normal over cosine of 20. Okay, so we can't really do anything with this yet because we don't know normal force. So let's find what normal force is. Right, so to find normal force, let's take some of the forces in the y. We're also going to assume we're at equilibrium in the y direction. Okay, allergies ceased, right? Okay, so what do we have, right? We have normal pulling up. We have P pulling at that angle, sine of 20, and then minus force of gravity. All right, so let's move that normal over to the other side because that's kind of what we're solving for. Wait, hold on, what am I doing? Gotta make sure I'm doing this right. Yeah, so we're trying to get normal out of this equation, so we're gonna put normal on the left here. We're gonna get negative P sine of 20 plus force of gravity, so plus mass times gravity. So again, we have two unknowns, so let's plug this normal equation into this normal equation. So we're going to get P is equal to coefficient of static friction. Then this is going to be plugged in. P sine of 20 plus mass times gravity over cosine of 20. And then, of course, we're going to split this up. This is going to become P is equal to, so I'm going to write the other side first, coefficient static friction times mass gravity over cosine of 20 minus coefficient of static friction, P tangent of 20, right? Because sine over cosine is that. So then if you want to get P by itself, of course we're going to move one of these over and we're going to get just, we're going to get P is equal to, P would be equal to coefficient of static friction, mass times gravity over cosine of 20, 1 plus tangent, or coefficient of static friction, tangent of 20. Okay, so this is what we end up with. So we can just solve by plugging in our numbers. So coefficient of static friction, 0.4, mass, B, gravity, 9.81, cosine of 20, coefficient of static friction. You know how to plug all those in, right? You get that this is equal to 291.6 newtons. Okay, so this is the force, basically, at which it breaks that static friction. So if we want to find what time this is, we're going to go to this equation here. P is equal to 90t squared, so we're going to plug in 0.6 is equal to 90t squared. And then if you solve for t, you get that t is equal to 1.80 seconds. So what does this tell us, right? Well, it breaks static friction at 1.8 seconds, which means that it does slip by the time we reach 2 seconds. So that means that we actually have to solve for acceleration. It's not just going to be equal to 0. So cool, we went through all this work just to erase it. So yeah, we'll go back. If you skipped all this part, we found that it does slip, so I guess we can kind of just get rid of most of this stuff. I'm going to keep it from here though, because I feel like the rest of this stuff is still true. So now we're here, but instead we're going to be in not static friction, but kinetic friction. Right. So we can go back to this equation, and also, never mind, I can't do this anymore, because the sum of the forces are not equal to 0 anymore. So let's just start all over, basically from here. Now the sum of the forces are equal to mass times acceleration in the x direction. And that's what we're solving for. So if we want acceleration in the x direction, I'm going to divide by x, or by mass, so you're going to get p cosine of 20 minus coefficient of static friction normal over mass. Oh shoot, I think I solved for normal, and then yeah, we solved for normal. I'm going to write it over here. Normal is equal to, I guess, force of gravity minus p sine of 20. All right, we found that earlier. So we can go ahead and plug that in now. P cosine of 20 minus coefficient of kinetic friction. That's what this is supposed to be. Times normal, which is force gravity minus p sine of 20 over mass. Okay, so now we can basically plug in everything we know. First of all, we just need to find what p is at 2. So to find the force of p at 2, we're just going to plug in 2 seconds. So it's going to be 92 squared, and that's going to be equal to 360. So let's just plug in everything to find that acceleration. So 360 is p, so 360, can't write today, but it's all right. Cosine of 20 minus coefficient of kinetic friction, so 0.3. Force of gravity is mass times acceleration, so the mass is 80 times 9.81 minus 360 for p, sine of 20, divided by mass, 80 kilograms. Make sure I get all this right. Yeah, it's looking good, it's looking good, oh yeah. Okay, and then you get acceleration x is equal to 1.75 meters per second squared. Cool. But yeah, that's how you solve this problem. We could have skipped a lot of steps, we could have just skipped right to this part, but it's good to know, it's good to prove that acceleration is greater than 0 because we slip. So yeah, that's how you solve this problem. If you have any questions, check out my playlist, ask in the comments below. Thanks for all your support, and I'll see you in the next video. Peace.